and I declare this power plant open.
I'm about to become a millionaire.
Hack and play.
This power plant will self-destruct in T-minus 10 seconds.
Wait,
9,
what?
8.
Illegal.
Now, in order to save my company, I'm gonna now teach you nuclear power and why that is never gonna happen. Firstly, let's see how atoms release energy. Protons are positively charged. Like the positive ends of magnets, they repel each other. The force keeping atoms together is strong nuclear force created by hadronic subatomic particles called mesons that bounce between subatomic particles. The repulsion force outwards is called nuclear binding energy. Therefore, the mass of the constituents is always greater than the atomic mass because some is expended in binding energy, proven by Einstein's theory of relativity. Therefore, we can calculate binding energy by subtracting them. Most atoms are stable, while others are unstable and easier to break. Unstable atoms have a tendency to release either alpha, beta, or gamma particles and some binding energy to become more stable. This process is called radioactive decay. Uranium-235 particularly goes through a process called alpha decay, releasing 2 protons and neutrons. But the important thing here to note is that uranium almost never splits into 2 different atoms by itself. When a uranium-235 nucleus absorbs an extra neutron, it quickly breaks into 2 smaller atoms, releases 2 to 3 neutrons, and 200 electron volts of thermal energy in a process known as fission. Since fission releases extra neutrons, these neutrons hit nearby uranium-235 and cause subsequential fissions and keep going on. This is a nuclear chain reaction, and using simple mathematics, we know that after 80 generations, there will be at least 1 mole of fissions, which is a huge amount of energy. To get the first neutron requires a neutron source. This is an element whose atom is super unstable and undergoes spontaneous fission, which is a mode of radioactive decay where atoms split into 2 smaller atoms plus excess neutrons by itself. The impact of a uranium atom and a neutron is most optimal at 0.1 electron volts. Let's imagine this plastic bag is a uranium-235 atom. The golf balls are the nucleons, and being such an unstable atom, adding 1 more golf ball will cause it to burst. Is launching the ball at a high speed or dropping it in with a high arc better? Slower is better since launching it often causes it to scatter or go careening. So in reactors, we use water as a moderator to slow the speed of neutrons. However, our biggest problem is controlling the chain reaction. As we know, fission is exponential, so if we don't control it, it will become a nuclear bomb! Control rods are used to control the number of fissions. They're made of elements that are more prone to absorb neutrons. When a reactor reaches its desired fissions, control rods are inserted to absorb extra neutrons to ensure only 1 additional fission each reaction. In this way, a steady rate of steam is generated, spinning a turbine, and power is generated. Alright, now I'm gonna upload everyone, play my video, and see what happens. Can I invest $10,000 in your company?